Hello, this is Jyothi and I'm Thanusha. We are business analytics students from IIT Tirupati. In this short live video, we are going to give an explanation of creating a local package for univariant analysis using Python. The prerequisite for this task includes the basic understanding of Python data structures, primary understanding of statistics, data visualization, and data manipulation. Data cleaning is a vital step for the sake of data analysis in any data science project. In data cleaning, univariant analysis is the primary step. That is done by plotting histograms and box plots for numerical variables, bar graphs for categorical variables. Let us consider an empirical scenario where there are immense number of variables. Then it will be a huge and tedious task to plot the graphs for each and every variable separately. Here, our motive is to build up a user-defined function which will automate this time-consuming process. So the time for generating the graph will be reduced and we can spend more time on examining and analyzing the graphs.
We will create an user-defined function in Python for plotting graphs. In basic step, we plot graph for only numerical variables in dataset. Defining a function def with function named as graph of dataset as an argument. Here we are importing pandas and numpy for data manipulation, matplot library for data visualization. For extracting numerical variables from the dataset, numerical columns is equals to ds.get numerical data from columns. X is equals to list of numerical columns. Using for loop, we plot histograms and box plot for or each and every variable in X. plt.savefig is for saving plots into working directory with variable name underscore histogram.png. plt.title is to show the title for the graph. Here, for demo purpose, we took card dataset. We'll be explaining each and every column of the dataset. The first column is cars, next is MPG, cylinders, displacement, horsepower, weight, acceleration, model, and origin. Next, we are going to explain you about how to create a user-defined function in Python.
We'll do some iterations to analyze data further. Iteration 1, plotting graph for only selected variables by adding an additional parameter columns. Function graph1 takes two arguments, data and columns. In this, user can input specified columns. Try and except were used here. In try, histograms and box plots were plotted for numerical data from the given input. If the user has entered categorical variables, in except, it just throws an error message to input numerical variables. In second iteration, if arguments for columns is ignored, then it will return graph for all the numerical variables in the dataset by default. This is done by using if condition. If length of columns not equal to 0, means user has specified columns, then it will plot histograms and box plots for the given input. Else, if user ignored columns in input, it will plot graphs for all numerical variables in dataset. In third iteration, an additional improvement for the previous function, even it will take the arguments data and variables, will return box plots and histograms for numerical variables, bar charts for categorical variables. This is done by using if condition. If length of columns not equal to 0, in try it will plot histograms and box plots for numerical variables, in accept bar charts for categorical variables. If condition doesn't satisfy, it will plot graphs for all variables in dataset. Here we separate numeric and categorical variables. As we know, num columns is numerical data. To get categorical data, numerical variables were separated from the total set of variables. Now, using for loop, it will plot histograms and box plots for numerical data and bar charts for categorical variables.
Coming to next iteration, we create a directory which enables the function to export all the image files to a specific folder. In function graph 4, we have additional argument directory for the user to specify. Here we import os.mkdir used to create directory, os.chdr is to change directory to save files. Now all the image files will be stored in a given directory. Finally, a local package is created to store this user-defined function. We have created a local package named Univariant for the above user-defined function. Now, before checking function, let's look at the output. There is a folder named plots in D drive. Here the graphs plotted for cars dataset is saved for each variable. You can see histograms and box plots for numerical variables, acceleration box plot for all the variables. And bar graphs for categorical variables. For illustration purpose, first we will be deleting all the outputs and we'll check the function now. Now we will open a test file. We'll import pandas. Import OS. Now we'll call the function import univar ss. We'll take cars data. We'll change directory. We'll use our function. We'll go and check there.
Here we can see the graph plotted for all the variables. Thanks for watching.